Hello, today I'm going to help you understand how one of the most common mechanical items you own works. The item I'm speaking of is the mechanical engine. Now before you shut me out, I'd like you to realize one fact. One of mankind's most significant obstacles, and the thing that halts most of our progress, is distance. From the field to our mouths, the opposition in eating is distance. The air we breathe, from the atmosphere to our lungs, the obstacle is distance. Obtaining riches from the earth, exercise, construction, space travel, getting something from point A to the place where we want at point B is one of mankind's most common and irritating challenges, especially when we want to turn on that old idiot box and the remote is nowhere to be found. In order to help us alleviate this problem, we invented wheels and wagons, but how to get the wheels to turn was always a challenge. Manpower was an option, oxen, horses, but these options were slow and we needed something to help it move a little bit faster. In steps the mechanical engine. As a society, we advanced at an alarming rate since the Industrial Revolution. However, the mechanical engine remains much the same today as it did since its inception. Gas-powered and the electrical-powered mechanical engines. We won't go into all the different parts and inner workings of the engine, so you can relax. No need to be an expert mechanic to understand. No, we're only going to talk about the different concepts, and returning to my original question, how do we get the wheels to turn? Obviously, we need force to make it move. So if gasoline is our chemical, how do we get it to have force? Well, we light it on fire, right? We blow it up. So now we have force, but we want this force to do two different things for us. Move the wheels and to move them in a specific direction. Now we can just put it behind the wheel and light it on fire, but that won't get us very far. So what we need to do is direct the force in some way, and the simplest way is by putting it in a container with an opening like a tube. This means that we light our gas in a force, and the force is going to go in one way. Now, if we insert something into this tube, the tube being this Nerf gun, and the Nerf ball being the thing that we're inserting, something not attached to the tube, and light the gas, it'll blow out just like a cannonball out of a cannon. But how do we get this to move the wheel in a circular motion? Just putting the cannon behind the wheel isn't going to get us very far. We can blow the wheel to smithereens, but it's not going to get the wagon to move exactly where we want it to. Now, as you can see here, there's a small mechanism inside my Nerf gun that allows it to move forwards and backwards. This we're going to call the piston for all intents and purposes, this being our wheel. By attaching it so when the piston is pushed out by the force of the explosion, it will move the wheel, but not the entire way. Let's say about halfway for this explosion. So now what do? Well, we reload and we fire again. However, instead of firing into the same one over and over again, if we stick another tube and attach it to the other side of the wheel, even though we only get a little bit of motion from each explosion, we are getting in such a way that the wheels are making a full rotation. So one explosion, then another explosion, then another explosion, each one coming from a different piston. On to the complex part, reloading. Now, it doesn't sound complex, but there are 4 things that any combustion engine needs in its combustion cycle in order to complete itself. It needs to put the gas and the air in, needs to put the piston back at the top, needs to explode, and needs to get the used air and gas out of it. So intake, compression, explosion, and exhaust. We can accomplish each one of these 4 steps with the directional motion of the piston. We start with an explosion. The piston is at the top, and at this time it is driven downwards. It is then driven back up by the next piston firing off, and as it does so, it spits out all the used gas. It's driven downwards again by the next explosion, and this time filling up with gas. And then finally reloaded back into place by the final piston exploding. On to electrical engines. So as you can see by this engine, there's lots of little coils of wire. These coils of wire is what allows us to make a north or south pole of magnetism simply by the way that we are driving electricity through it. This is also ironically why we're not able to use something like a permanent magnet inside of these engines. Now if a permanent magnet were stuck in there, it would be stuck at north or south, and once it rotated and the magnet found its equal pair, it would have either stay there or repel from it and find eventually a solid state where it wouldn't move from. So what this engine does, the clever little bugger, it has a north pole at the back of it and a south pole at the front of it, where the magnet will always constantly be pushed away from and pulled towards the other magnet, so that as it rotates, it will constantly change, so it'll constantly be pulled and pushed at the same time, and the polarity of either north or south will never actually be directly where the magnet or the coil of wire is. And that's it. You've achieved circular motion. Whether through mechanical and gas-powered means or electrical mechanical means, think about it. What engine and what object in your house which will move doesn't move some way in a circular motion? Anything from the blender to the weed eater to the lawnmower to the car engine, everything has a circular motion in which it rotates. And this is because that is the motion which is required by mankind in order for us to make our lives more effective.